Greetings and welcome back for another Music Theory Bite. Today we're going back to basics to talk about beats and how they organize themselves into meters. If that sounds like something you'd like to learn more about, then this is the video for you. Rhythm and meter deal with the aspect of time in music. That's essential because time is a critical component of music. Music exists in time. So in this video, we're going to talk about the very basics of meter, how beats go together to create meters. Because the topics of rhythm and meter can get fairly complicated, we're just going to cover that very basic topic today, and you'll hear me say several times throughout this video that other topics that I touch on will be covered in later videos. Not trying to hide anything from you, I'm just trying to break it down into small, manageable chunks in order to make it easier for you to learn. So, let's get started. A few terms before we start out. A beat is a unit of measurable time in music. Beats differentiate themselves by having different strengths or amounts of temporal emphasis. When these beats of different strengths are organized into a repeating pattern, we have meter. So, meter is a pattern of regularly recurring strong and weak beats. It's the underlying temporal framework of a piece of music. When we write music down, musicians will use bar lines to delineate each repeating metric unit. The bar lines separate what we call measures. Meter signatures tell musicians how they can expect to organize the music metrically. We'll talk more about meter signatures in a later video. We place rhythms on top of this metric framework. Rhythm is the specific placement of musical events in time. Rhythm is something that can get pretty complex, so I'll cover that in several other videos later on in the series. So let's start talking about meters. Meters have two characteristics, metric number and metric division. Metric number refers to how many beats occur in each metric unit, or the recurring pattern of strong and weak beats. There are four possibilities. We can have duple meters, in which there are 2 beats in each pattern, triple meters, in which there are 3 beats in each pattern, quadruple meters, in which there are 4 beats in each pattern, and mixed or irregular meters, but I'll cover those in another video. Let's start by setting up an undifferentiated beat. The symbols before you are quarter notes. We'll talk more about the rhythmic notation and the symbols we use for rhythm in a later video. We'll say that each of these represents the sound of one beat. Keep in mind that we can assign any durational value to receive one beat. Quarter notes tend to be among the most commonly used for this purpose, so we'll use them for this demonstration. As I said before, there are 4 types of meters. We have duple meters, where we group 2 beat notes in a strong, weak pattern. Notice how on my notation, the addition of bar lines occurs after every second quarter note. These visually show the musician where the metric groupings are. The space between each bar line is called a measure and represents an entire metric unit. Triple meters group 3 beat notes in a strong, weak, weak pattern. Notice how the bar lines have now shifted. Each measure now has 3 beat notes. Quadruple meters group 4 beat notes in a strong, weak, medium, weak pattern. And of course, we also have mixed and irregular meters, which will be dealt with in later videos. The meter you happen to be in isn't always crystal clear to one's ear. One person's duple meter can be another person's quadruple meter. This is because of the concept of hypermeter, or the grouping of metric units into larger metric units. We can think of a quadruple meter as being the same as 2 duple meters put together in a strong measure, weak measure relationship. Let's move on to the topic of metric division. Metric division refers to how the beat note is divided. We have two types of metric divisions. We have simple division and compound division. In simple meters, the relationship of all note values to the next larger and next smaller note values is a 2-to-1 ratio. So for example, the beat note always takes up one beat. In a simple meter, because all the ratios between adjacent durational values is 2-to-1, when I divide the beat note the first time, I end up with two equal notes. When I divide that again, I end up with 4 even notes within a beat. Divide it a third time, I will end up with 8 even notes in a beat. And a fourth time, I'll end up with 16 even notes in a beat. What results is a very straight up, almost square feel to the music. In compound meters, however, one of these 2-to-1 relationships is replaced with a 3-to-1 relationship between the beat level and the first division of the beat. So for example, my beat level has one note. When I divide it the first time in a compound meter, I will end up with 3 equal notes. All remaining divisions maintain the 2-to-1 ratio. So my second division in a compound meter will have 6 even notes. My third division will have 12 even notes. And my fourth division will have 24 even notes. When you compare the sound of a compound meter to that of a simple meter, you'll notice that it has a much more lilting feel to it. Once we know a meter's number and division, then we can both describe it and write a meter signature for it. We'll save writing meter signatures for another video. In describing it, we first say the metric division, then the metric number. So we can have simple duple, simple triple, and simple quadruple meters. We can also have compound duple, compound triple, and compound quadruple meters. How can we make this practical? For now, start listening to music with a particular emphasis on paying attention to its meter. First, listen for the beat. Once you've found the beat, listen for the groupings of recurring patterns. Find the strong beats and count how many beats occur until the next strong beat. That will tell you the metric number. Next, listen for how the beat is divided. Is it in 2 even parts or some multiple of 2, giving it a somewhat square or straight up feel? Or is it in 3 even parts or some multiple of 3, giving it a lilting feel? This will tell you the metric division. Understanding a meter's number and division will become very important, first as you learn to write meter signatures, and second as you learn to write rhythms correctly. As I said before, we'll save those topics for a later video. Well, that does it for this Music Theory Bite. If you found it helpful, please like, and if you'd like to learn more about music theory through this video series, please subscribe to my channel. If you have comments, you can leave them down below. So, until next time, keep making music.